Hey there, gang. Welcome back. I've got some really nice 5-string banjos in the shop right now, and I've been asked to install some traditional spike capos into these. That's some old backwoods problem-solving technology from the 1900s. Quite at home on these old frailing or clawhammer style banjos. Just a way of raising the pitch on the 5th string up to play in different keys. And yes, I will actually get to hammer nails into a pristine ebony fingerboard, which is something I don't do all that often. This one here with the maple pot is made by Mike Ramsey in Pittsboro, North Carolina. Really quite beautiful. It's got an astronomical theme here. It's pretty cool. This one's made by Kevin Enoch. It's got a walnut neck. And look at the transition here. I love this. This is just like it's almost like a baseball bat. Little filigree cutout there. Very restrained in its ornamentation otherwise. So way back when, in the days of yore, before mechanical capos were available or affordable for someone who built their own banjo out there on the homestead, if you wanted to raise the pitch of your 5th string, you probably got yourself a piece of baling wire, hammered it into your fingerboard, made a little hook in there, and just hooked the string under that. At some point, however, someone got the really bright idea and realized these things are already readily made. These are actually model railroad spikes used for attaching the track onto the sleepers. These happen to be HO scale, and as you can see, I've got more than a lifetime supply here. They're about 9 millimeters long, or 3/8 of an inch, and they're really quite diminutive. Difficult to work with, but perfect for this because they're hard and you can pound them in. Now as these come, the little leg portion here is slightly longer than it needs to be. And following the advice of venerable guitar repair guy Frank Ford, I'm going to shorten that slightly by filing and also radius the corners a bit and make it nice and soft in the event that you actually have to touch it at some point. Just a little bit. Something to consider before we begin here is the 5th string nut, which as you can see is actually quite a bit taller than the 5th fret itself. That's not always the case. Some manufacturers have these very low and the string takes off as if from a 0 fret. But we've got an extra 3.5 millimeters or so of extra string length on here. And that means that when we put the spikes in and hook the string under them, we'll be raising the pitch minus that extra string length. So it's not likely to play in tune and will require retuning before you begin playing. I talked to the customer about this. Other people would insist on lowering that. He says that functionally, when you put the string under there, you almost always have to retune anyway, so it's not such a big deal. He wants to leave it at this height. He'd like these on the 7th and the 9th frets. And in terms of placement, I'm going to go on the inside or treble side of the string, and it'll be about 8 millimeters away from the fret itself. That'll give us good downward pressure for clear tone, but also enough slack that we can get it between the spike and the fret itself and hook that under without too much difficulty. We had discussed maybe putting it on the bass side. Looking at this though, there's very little room between the edge of the spike and the edge of the fingerboard, and I don't want there to be any chance that this would crack or split off or maybe deflect while it's going in there and coming out the side of the neck. That would be pretty unsightly. So I'm going to do what most people seem to do and put that on the inside. And we're going to need to drill a little pilot hole here, obviously. We can't just pound these right into the ebony fingerboard without some kind of direction. So I got to find a very small drill bit. Using my dial caliper here, I see we've got about 32 or 33 thousandths of an inch, which is about 0.8 millimeters. Pretty small. Checking through my collection of various bits, I've got this end mill here, which is about 27 thousandths of an inch, 5 thousandths smaller than the shaft of the spike, which should give us a really good clearance hole. Really small, so we're going to have to be careful while we're drilling. I'm just using the point of an awl here, not going too deep, just to give myself a reference mark. As it turns out, the fluted portion of this bit is about the depth to which I want to drill, so I don't have to come up with some other kind of drill marker. I wouldn't want to wrap tape around this thing. Obviously no pressure at all. And going slow, I don't want to develop too much heat, and I'm going to be stopping incrementally so that I can clear off the bit and let it cool down. Just using some shim stock here to make sure I don't go too deep and also protect the frets and the fingerboard. The board on this Enoch is made from Richlite, which is a synthetic material. Seems to really resist the nail, so I'm actually sizing up a drill bit size here. Drilling a hole that's about the same diameter as the shaft itself. I'm going to super glue this in at the right depth. Shim stock is about 13 thousandths of an inch thick.